quotient rule of exponents. So here we are talking about the rules of exponents. We just went over product rule, power rule, and now we're at the quotient rule. So quotient means division. So here, when you have a to the m divided by a to the n, so division, fractions are another way of saying dividing. So a to the m divided by a to the n, or division, what you're going to do is you are going to subtract the exponents. So m minus n. M minus n. And in other words, it's the top minus the bottom. So top minus bottom exponent. So always remember top minus bottom. So here, this is the quotient rule. Let's go ahead and take a look at a few examples here. So let's start with just a simpler example. So what if I gave you something simple like x to the fourth divided by x to the third? So here, what that means is that you subtract the exponents, the top minus the bottom, so you get x to the first power, or just x. Now, again, I like to ask the question, why? Why is this the case? The reason why this is the case is if I did it the long way, in other words, if I did this the long way, x to the fourth is x times x times x times x. X to the third is x times x times x, 3 times. And notice when you have something like this, sorry, when you have something like this, you could cancel out common factors here. So x divided by x just becomes a 1, and x here again becomes a 1, and another x gets canceled here. So what are you left with? Just 1x. And voila, that's the same answer as a shortcut. So the ones on the top cancel out with the ones on the bottom, or divide out with the ones on the bottom, and what you're left over with is whatever's left on top. And that's the same idea as subtracting the top minus bottom. So let's look at a few examples. Let's look at number 8 here, where we're going to be using this quotient rule. And you know that you're going to be needing the quotient rule because you have division here. So here, first off, I'm just going to look at the numbers. 12 divided by 18. Well, 12 divided by 18, 12 and 18 have what in common that can divide out? They have a 6 in common. They also have a 2 in common and a 3, but the biggest number that they have in common is 6. So 6, so 12 divided by 6 will give me 2. 18 divided by 6 will give me 3. So I've just simplified 12 over 18 and got 2 over 3. Now, the next one is w over w cubed. So let me just write this out on the side. So 12 over 18 now becomes 2 over 3, right? Now I have w over w third. So now I have w over w to the third. What does that become? Well, the w here is a 1 exponent. So I'm going to use the quotient rule where I subtract the top minus the bottom. So I get w to the negative 2. I'll talk about negative exponents in a second, but right now I get w to the negative 2, okay? Last but not least is x to the fourth divided by x to the fourth. So here, x to the fourth divided by x to the fourth, what does that become? Well, you could just think of it as canceling out and this becomes the number 1, or you could think of it as the top minus the bottom. X to the 4 minus 4 will just give you x to the 0 power. And I haven't talked about this yet. We'll get to this in number 10, but anything to the 0 power is always equal to 1. And if you don't believe me, or in case you forgot why or how that's the case, if you push 5 to the 0 power, anything to the 0 power, you push enter, it will give you the number 1. So if it's x to the 0 power, anything to the 0 power will always give you 1. So now when I combine all these things, it's 2/3 times w negative 2 times 1, which is just 2/3 w to the negative 2. In a second, in another example or another rule, we're going to talk about negative exponents. The key thing is that you cannot have negative exponents in your answer, so we're going to have to do something to change this. But I'll talk about this in a future video. But for now, this would suffice in terms of the answer for the quotient rule. But again, once we learn the quotient rule or the negative exponent rule, we'll go back and fix this problem. All right, let's look at question number 9. So question number 9 here, question number 9 here it's a combination of exponent rule and quotient rule. I'm sorry, the power rule, because there's a exponent raised to the power and a quotient. So this is quotient and exponent, and I'm sorry, power rule. So again, we could use more than one thing in one problem, right? So when I look at this, I'm gonna do the quotient rule first because here's the exponent, but inside the parentheses is what I'm focusing on first. So if you remember the order of operations, parentheses goes first. So I'm gonna ignore the exponent for now. So when I ignore the exponent for now, I'm just gonna focus on what's inside the exponent, which is this parentheses. So when I look at that, I ask myself, can I simplify that? And the answer is yes, I see an A and an A. So A3 over A5. So here A3 over A5, top minus bottom, 3 minus 5, that'll give me A to the negative 2. So I can rewrite this problem now as, right now I have 3, this A and this A to the 5th now becomes A to the negative 2 over, I had the 4, A3 over A5 became A to the negative 2, so I don't have to worry about that, then B squared. So that's what the parentheses simplified to. And now this is going to be raised to the second power. So now I'm going to use the power rule, and the power rule says that I am going to distribute this 2 into the parentheses to every single item into the parentheses. So when I distribute it through, 3 squared, 3 times 3 is 9. A to the negative 2 raised to the squared power. So if I have a power rule, what do I do with the exponents? Power rule, I multiply the exponents, right? So when I multiply the exponents, I get A to the negative 4. The bottom, I have 4 squared. Well, 4 squared is 4 times 4 is 16. B squared squared, you're going to multiply the exponents to get B to the 4th. And 9 over 16, I can't simplify that anymore. And again, I mentioned earlier that you cannot have negative exponents in your answer, but for now, we'll keep it here, just like we kept this one with the negative. And then once I go back to negative exponents, that rule, we'll revisit these problems to write it the correct way.